Okay, so what I want to do today is just show you a program. It's just a made up program. And imagine, if you will, there's an earthquake. Don't worry, it's just imaginary. What's happened is there's an earthquake underground, and the vibration from the earthquake goes through the rock and soil, I guess, and it comes up to the surface. And what we have is multiple receiving stations which listen to when these vibrations arrive. And then, because the location of the stations is fairly random, the vibrations also arrive at a random time. So, having said that, if you know when and which station had the first vibration, then you could go backwards, use a bit of least squares and uh, and figure out where the location of the earthquake was located, and that's what this does. So let me there's my screen, and here's my program, and I use NumPy. I show the results with matplotlib. This is in Python, by the way, and then I use SciPy to do the mathematics. So I have a a few defined uh, subroutines. Now, the first one is generating the station positions. All this is imaginary, so each time I run this, I have a different location. I have 7 stations, and I just change it a little bit so that they cover a certain area. And then I've got I make a true point of the earthquake, which is really not a true point. It's just a theoretical point. And then the next two uh, subroutines, they come up and figure out a random time for all the signals to appear at the different stations. And eventually I get down to the point where I run the program. N equals the number of stations, and then I go down to 30 kilometers, a 30 kilometer radius and a 10 kilometer depth. Earthquakes can occur at that depth or maybe lower, but this one is just pretend. And so I can run this, and it doesn't take too long. And what I've got here is a picture of or a graph of the earthquake. And I can zoom around. You can see that the blue stations, the receiving stations, are at different altitudes or elevations. And you can't see it, but there's a true earthquake star, a green star, behind the estimated earthquake. And then down here, you can see that these are the X, Y, and Z. And the difference in depth is about 60 meters between the true and this is based on the fact that I've just made a bit of random noise in the earthquake. So we can run this again, get a totally different earthquake, and this one's a lot lower. You see, it's outside the radius of the receiving stations, and the geometry here is not as great. So it's 120 meters off. Still not too bad. So that is my earthquake detector. I hope you liked it. You can grab a copy and play with it if you want. Hit like and subscribe. And wait a minute, I'm not on whatever that was to do like and subscribe. So I hope you liked it. Bye now.